In this video, we will be determining side length using the cosine ratio. In an earlier video, we determined that the cosine of angle C is the length of the side adjacent angle C, which is CB, divided by the hypotenuse, which is AC. We know the hypotenuse in the diagram on the right to be 10. Let's assume that the angle C is given as 36.9 degrees, and the hypotenuse is known to be 10. No other sides are known. How do we determine the length of the side adjacent to angle C? We can use direct measurement, and clearly CB equals 8. We could also use indirect measurement and use the cosine ratio. The cosine button on a scientific calculator produces a real number, a fraction or a decimal, when you use it. In other words, the cosine of an angle is a real number. For example, the cosine of 36.9 degrees is 0.79968 continuing. Recall the cosine button on your calculator as indicated in the red rectangle on the right. Recall also that the angle must be in degrees. Here's what we have. Cosine of 36.9 degrees equals CB, the adjacent, divided by the hypotenuse 10, which now can be thought of as 0.79968 equals CB over 10. If we multiply both sides by 10 and cancel the 10s on the right side, we get 0.79968 times 10 equals CB. Therefore, CB equals 7.9968. And this is consistent since we already know that CB equals 8. Here's an alternate solution. We could solve cosine 36.9 degrees equals CB over 10 and write cosine 36.9 degrees over 1 equals CB over 10. Because we know that cosine 36.9 degrees can be written as 0.79968 continuing over 1, simply because any number can be written as a fraction with a denominator of 1. We cross multiply, we get 1 times CB equals 10 times cosine 36.9 degrees, giving us CB equals 10 times cosine 36.9 degrees. We now use our calculator, and 10 times cosine 36.9 degrees is 7.9968,46585 continuing. CB equals 7.9968 as before, and now we can think of CB as just simply 8. Here's example 1. Determine the length of RQ to the nearest tenth of a centimeter. We know that cosine of 34 degrees is the side adjacent angle R, which is QR, divided by the hypotenuse RP, which we know to be 84 centimeters. We get cosine 34 degrees equals QR over 84. Using our calculator, cosine 34 degrees is equal to 0.829037573 continuing. Rounding to 4 decimal places, we get 0.8290 equals QR over 84. Multiplying both sides by 84 and canceling the 84s on the right side, we get this, 0.8290 times 84 equals QR. QR is 69.636. Rounded to the nearest tenth, we get QR equals 69.6 centimeters. Rounding, though, may lead to some discrepancies. Here's an alternate solution. We could solve cosine 34 degrees equals QR over 84, write it as cosine 34 degrees over 1 equals QR over 84. Because we can write cosine 34 degrees as 0.8290 over 1, because any number can be written as a fraction with a denominator of 1. We cross multiply, we get 1 times QR equals 84 times cosine 34, giving us QR equals 84 times cosine 34 degrees. Turning to our calculator, 84 times cosine 34 degrees is 69.63915609 continuing. We get QR equals 69.6 centimeters as before. Here's some practice. Determine the length of NM to the nearest tenth of a centimeter. You may wish to hit pause here and try this on your own. Cosine 64 degrees is the side adjacent angle n, which is nm, divided by the hypotenuse ln, which we know to be 9.6 centimeters. We get cosine 64 degrees equals L over 9.6. We can now write nm as simply lowercase l. Writing cosine 64 degrees over 1 equals L over 9.6, and cross multiplying we get 1 times L equals 9.6 cosine 64 degrees. We get L equals 9.6 cosine 64 degrees. We take our calculator, we multiply 9.6 times cosine 64 degrees, we get 4.208363009 continuing. Rounding to the nearest tenth, we get L equals nm equals 4.2 centimeters. Here's an alternate solution. Angle L is 90 degrees subtract 64 degrees, giving us 26 degrees. Now instead of the cosine ratio, we could use sine. Sine 26 degrees is the side opposite angle L, which is nm, the side we need, divided by ln, the hypotenuse, which we know to be 9.6 centimeters. We solve sine 26 degrees equals L over 9.6, once again because nm can be written as lowercase l. We can write sine 26 over 1 equals L over 9.6 and cross multiply. 1 times L equals 9.6 times sine 26 degrees. We get L equals 9.6 times sine 26 degrees. We turn to our calculator and 9.6 times sine 26 degrees equals 4.208363009 continuing. Rounding to the nearest tenth, we get L equals nm equals 4.2 centimeters as before. Please proceed to the next video in this lesson, and thank you for viewing.